back side of the notes here, we're going to be focused specifically on domain and range. We're not evaluating. We're not worried about necessarily too much going on here, except for let's go ahead and pick out the domain and range. I'm not even worried about intervals, just domain and range. The very first hint that I would give you, I think, for this scenario here is let's go ahead and pinpoint exactly what's happening with the arrows first, because that's going to tell us a pretty big story. So I'm going to go to the arrows, and let's just highlight these locations. There's an arrow, there's an arrow, there's an arrow, and there is an arrow. All right, and when I see those arrows, I'm not going to get very wordy with that. I'm just going to label where are those arrows heading, what are the directions, both left and right and up or down. So the arrow here on the left problem, on the left piecewise function, that arrow is definitely traveling to the left, and it is heading downwards. Two different directions for that arrow. I would say that the arrow here on the piecewise function that is on the left side of our paper would be traveling to the right and is also heading down. If I go to the problem next to it, that arrow is part of a horizontal line, a constant interval, if you will. So it is only going to the left. There is no up, there is no down. And then this one right here is a kind of sort of a tricky one to finish up with. There is no such thing as an arrow pointing straight up or straight down for a function. So I definitely see that it is going up. However, we do want to make sure we understand that it is going to the right as well, ever so slightly. It's not a lot of going to the right, but eventually it's going to the right as much as possible to infinity. So what does that mean? As a reminder, the words left and right are x values. The words down and up are y values. What I can do here is I can go ahead and install that into my domain and range right away, because I know that it covers every piece that's not on the graph, everything that's not on the graph. So I think I was using purple for this. The left and the right are phrases that cover us as we travel in those directions for the x values. So it is fair for me to say that if I have a word or have something going to the left, that on the left side of my compound inequality for domain, it is going to be negative infinity. The same thing for the right. If I'm having something travel to the right, then I know that this is going to travel to positive infinity. The one thing we want to make sure that we do before we kind of finalize things is we want to make sure that we cover everything in between. Remember that domain is an X word, so I'm going to go ahead and highlight and just make sure I understand that as I look on that purple highlighted line, that there's a point somewhere above it or below it, and that is the case for this scenario. One last thing to mention in this scenario for domain is that we never quite get to infinity or negative infinity. So when I write out this compound inequality, we want to use arrows that don't have lines underneath them, because we're never going to quite reach negative infinity, and we're never actually going to get to positive infinity. By definition, that's impossible. All right, the next thing up for us here is the range, and our range directions, we see two downs. We don't see an up. That tells us a little bit too about this. So in terms of down, we know that the word down is a negative y value. So I'm going to be able to write that this piecewise function is going to travel to negative infinity. Actually, twice. There's two pieces that travel to negative infinity for our y values. There is no up. Since there is no up, that probably means I'm going to have a maximum in this problem. I'm going to be able to figure this out. So I do want to take a moment here, and I'll do the same exact thing I did with the x values. I'll travel here, and even when I go off the screen, that's got the arrows covering it. We know the arrows would eventually get there. And I'm drawing this line, or I was drawing this line, where everything is, all the points here that I'm drawing have y values. And then we get to this spot right there, and there is nothing above that location. We know that that location, y value-wise, is a 4. We have to pay attention to the dot. Is the dot included or excluded? It is excluded. What does that mean? That means that the arrow does not get a line underneath it. It's not a colored in dot. If that was an included point, then we would color the arrow, we would draw a line underneath the arrow. So that's our domain and range for that particular problem. Let's go ahead and try out the second one. I see arrows to the left and to the right, or pointing in those directions. I want to make sure that I cover myself here. And as I draw this purple line, I could figure out at least one point that would have those values. And you might be saying to yourself, well, Mr. Berry, what about over here? There's not really anything over there. Well, on this picture, you're right. However, we know that that right marking, the arrow traveling to the right, will eventually cover things like 3 and 4 and 5 and 6 and 7 and 8 and so on. So I have a left, I have a right. Pretty straightforward. I'm going to be able to say the domain is traveling from negative infinity to positive infinity for our x values. Range is a little bit different of a story. It's kind of sort of tricky, especially tricky because we know that we hopefully can sort of see a little bit of a gap. I'll get there eventually, but before I get there, let's go ahead and make sure that we understand that we do have the word up, which means we are eventually traveling to positive infinity for our letter y. This one's a little weird, not going to lie. We see a lot of action here at -6, right at that location. There is a horizontal line, it is constant interval, it is flat. And then we start up with this again, and we know it travels to infinity. So, how do we cover something like that? Well, we need to mention this -6, and we need to mention the fact that, again, we have a piece up here that the bottom of that particular piece is right there at a height of 0 for a y value. So, the one traveling to positive infinity, that point is 0. That piece right there on the top is 0. That y value is 0. And that dot would be colored in. It's part of a line. I don't see it specifically called excluded, or there's not an open dot on that location for 0. So I'm going to draw a line underneath that. I do also want to mention, like I said before, the fact that I'm also going to have a range there at -6. So I'm just going to go ahead and mention that there is something going on at -6, specifically for the range, and I'm going to cover that constant interval. So it is possible to have two things there marked, right? We have that conversation at -6 for the y value, and we have 0 is less than or equal to y, less than positive infinity.